Hi viewers, welcome to LMS Solution. Today we are going to see about the solar PV fed BLDC motor based water pump under partial shading condition. I am going to explain about solar PV fed BLDC motor along with the hybrid PO-PSO MPPT. Here we are going to make some partial shading condition for solar PV system. We want to test the system with two condition. One is uniform irradiation condition as well as non-uniform, that is partial shading condition. And also here we have to test the system with the hybrid PSO MPPT and PO MPPT for the same condition. Right now I am going to simulation model. This is a simulation model developed for that solar PV flood and BLDC motor for water pumping application with the partial shading condition. So now to create the partial shading condition, we have two PV panel, both are connected in series. Each panel will be provided around 1700 watts power. And here you can see that the PV, both PV panel having constant temperature around 25 degrees Celsius. And then here we have provided that the irradiation for the first panel with the two logic. One is with steady irradiation condition, that means uniform. That means we are going to fix here 1000 in here 1000 means that means we have to fix the same irradiation for first panel and the second panel. Then the condition was uniform irradiation condition. When you have to fix the irradiation for both panel at a different irradiation level, it is known as non-uniform. Otherwise, it is called partial shading condition. So here you have used that Zeta converter in between BLDC motor drive and the PV panel. Then here the theta converter going to be used to for that means it will be operate both mode like the buck mode as well as boost converter mode. And here you can see that we are going to measure the PV panel voltage here and then voltage across this two panel here. This is given to MPPT algorithm. Inside we have that hybrid PO-PSO. And also here we have selecting switch. We can when we go to feed the data at 0 means it will be operate at the hybrid PO-PSO MPPT. When you have to put 1 here, then it will be act as that means it only operate in PSO MPPT mode. And then when you go to put 2 means it going to operate in PO. This block inside. This is a hybrid operative analog that PO-PSO. Here we have that PSO code and this is PO code. Here we created that logic, hybrid logic. I explained and then when hybrid PO-PSO and PPT already I explained in last videos. So you can check my YouTube channel more about that hybrid PO-PSO and PPT. Finally, it will be generated the duty cycle and then its process way during generate. That NDPT will generate duty cycle. Its process way during generated, it will generate the pulse for this. Based upon that pulse, the power in the PV panel will be expected at the maximum point. Here we have voltage source inverter. This voltage source inverter is controlled by means of all sensor output from the BLDC mode. And then here we have not implement that water pump concept. You have to take the feedback of the speed and then you have to take square and then you have to multiply it with the gain. That means constant. That means relation between torque and speed gain value. It is given to the torque input for the BLDC mode. It going to be act as a water pump based upon that logic. Here the torque which is equal to K into omega square. This is a equation for that water pump. And here we have measured different parameter like the irradiation of two solar panel temperature, PV power and output power from the Zeta converter. And then here we have to measure that converter output voltage and current. Here we are measuring that stator current of the BLDC motor, EMF, speed and torque of the BLDC motor. Now I am going to operate this model at uniform radiation. That means I am going to fix the radiation for both panel which is equal to 1000 pascal and I am going to test the response of the system under hybrid PO-PSO. Under here the panel ratings are around 3400 watts at the standard radiation condition. Now we can check the result of the system under hybrid PO-PSO MPPT. Here you can see that irradiation maintained for both panels is around 1000 watts per meter square at temperature is around 25 degrees Celsius. So this is the PV power. Here you can see that the PV power is trying to reach that maximum point. After some time, it going to reach that maximum power point. This is the power of this converter, then converter output power. Here you can see that this is a converter output voltage and then this converter output current. This is known as stator current of the BLDC motor EMF of the BLDC motor, speed of the BLDC motor, and torque of this motor. Here you can see that it reached that maximum point. Maximum power point is around after is try to reach that maximum power point. We wait for some time and then we check the results. Now we can see that the point is reached at the maximum point level when we are using that the uniform irradiation in the both hybrid PO-PSO and BBT. Now I'll maybe change the EBBT to PSO and then we'll check the response. Here you can see that the power extraction from the PV power initially it goes to maximum point. After some time it comes down because of the what happened that we are generating that duty cycle initially at random manner based upon the random value what happened the maximum point or power from the PV panel will be changed. After some time, what happened after couple of iteration when we find the optimal duty cycle not to extract the maximum power from the PV panel. That is the process happen in the PV. It will take some time to find the optimal duty cycle in order to extract the maximum power from the PV panel. Here you can see that this for every at time, every step time, each then the power, the peak power comes to local maximum power. This is because of that random duty cycle at the initial iteration. After some couple of main iterations, try to reach that maximum point with the optimal duty cycle. This is a process of that means working of the PSO MPPT. But what's the problem in the PSO MPPT? Already I discussed in that hybrid PO-PSO MPPT in the last video. You can check my YouTube channel. Once the irradiation going to be changed, it will take long time to find out the optimal duty cycle point for extraction of maximum power. That is one problem. And also sometime it will be comes to local maximum points. It's also happening this is by using PSO MPPT. And also when you go for PO-MPPT, the same in local it will track under the local maximum point. This is a problem of PO and also in PO it will take long time to reach the maximum point. So now I am going to it reach the maximum point and then AD pump irradiation condition. Now I'm going to change the system PO MPPT. That means I'm change the mode to PO HDT and then I'm going to check the response. Here you can see that this is a P power initially is trapped in the local point and then again is increasing and PO it try to at the maximum point but it takes some time. It takes long time when even you compare the hybrid PO-PSO BB, it will takes less time to reach that optimal duty cycle point or to reach the maximum power point. But you can see that the response of PO-MPPT in the solar PV powered BLDC motor. What it will take long time to find out the optimal duty cycle or to extract the maximum power from the PV panel. Here you can see that it not to reach that maximum point, it is finding the duty cycle, optimal duty cycle. This keep on varying depends upon voltage and current input to the MPPT algorithm. We are not getting the maximum power point. It again oscillating. You can see that here after reaching local point, it oscillating. After settling at some local point, is oscillating, and also you can see that is nearer to that maximum point, but here also the power is biased. This is the problem in the PO-MPPT. For that only we go for hybrid PO-PSO. When we go for hybrid PO-PSO, what happen? Maximum power can be extracted quickly and also you will get the exact results. So next I'm going to get the model with partial shading condition. For example, I'm going to change the time which is equal to 1. After 1 second, I'm going to change the radiation from 1000 to 500 and then you got to check the response. First time you got to change the MPPT algorithm to hybrid PO, yes, MPPT, and then you got to check the result of the PV power of the system, and also you got to check the result of collimator voltage, current, and then stator current, EMF, speed, and torque of the BLDC. Initially, it will be work like a uniform irradiation condition because both panel having 1000 watts limit. What will happen after once again? The radiation of the first panel. Here you can say in the first panel the radiation change from 1000 to 500 watt. The partial shading effect will be is given in the first panel. Even though partial shading condition, we need to extract the maximum power from the how that hybrid will extract the maximum power from the system, and also we have to check the response of the BLDC motor here. You can wait for 1 second and we check the response. Now you can see that the partial shading effect is occur here. Here you can see that one panel irradiation is maintained at 1000, another panel irradiation maintained at 500. Here the panel irradiation is 500, that one first panel having partial shading effect. Here you can see that after that, here you can see the power is maintained at around 1800. This extracting a maximum power from the panel. From this, that means you can see that by using the hybrid PO-PSO, the maximum power and the partial shading condition also set maximum point. The hybrid PO-PSO MPPT is expect the maximum power very efficiently in the solar PV power and the BLDC motor system under partial condition also. Let me change the response. Let me maybe change this to PSO and then check the response. Here the initial validator from 0 to 1 second. It will be the panel will be accuracy a uniform irradiation condition. Both panels having 1000 meter square. After 1 second, the first panel irradiation changed from 1000 to 500, and that means here the partial shading points up is created for the panel 1. We need to check the response of the system under PSO MPPT, and then you have to check the response of the PV power of the PV panel. And also here you can see the response, the same response, that whatever power is available in the system, that will be delivered to the BLDC motor. We will wait for 1 second. That way, here after 1 second, what happened that the irradiation changed from 1000 to 500 the PV panel 1, and then we check the PV power extracted from the PV panel under PSL. Now we can see that the power rating is around 1200, but already I see that power extraction from hybrid PO-PSO is 1100. When compared to normal PSO, VP10, PM, hybrid PO-PSO and we would extract the maximum power exactly from the PV panel for that water pumping application. So this comparative analysis between hybrid PO-PSO, MPPT and DO at the PS and DP for solar PV powered BLDC motor for water pumping application. So thanks for watching our videos. I subscribe our channel and also click bell icon for notification about upcoming video. Thank you. Thank you so much.